This is a refresh of little bit of Algebra 1, but then Algebra 2, and even geometry. Solving quadratics, solving multi-step equations, solving literal equations. You may not remember what a literal equation is, but I'll show you. This is just a reminder of, do you remember how to solve equations, especially quadratics? Okay, so the very first example that's up here is a multi-step equation. There are two of these in your chapter R exam review. Just a reminder that the order of operations written correctly should show that multiplication and division are interchangeable. It's based on what you've come to first. Same thing with addition and subtraction. If you are simplifying, when you simplify an equation, you do the order of operations in the order that you've been taught. You find all the parentheses and you do anything that's inside of it that you can. Find all the exponents, you evaluate them. Then you read it like a book from left to right, and you evaluate all multiplication, division, and so on. When you are solving, once you simplify, now you're ready to solve, then you go in reverse. You move all addition and subtraction stuff away from the variable that you're trying to get by itself. Then you divide or multiply. Then any exponents, then parentheses. All right. So let me show you. First, I cannot solve this until I clean it up, right? This needs to be distributed. So I'm going to bring this down. And then now I have terms that need to be combined. Y'all agree? Okay, is it completely simplified? Simplified. Like, there's no like terms, right? Now I can start solving. I need to move things to the other side. So I tend to move the variable. If you'll notice, we have here and here. I tend to move the one with the smaller coefficient because then I run into fewer negatives. So it doesn't matter which one you move. You can move the 2x by subtraction. I'm going to move the 6x over here by addition. Now, because my variable's on the left, that means I need to move the 3 to the right. And then divide by 8. Please be careful here and don't write the answers too. Always, at the very end like this, always think of it as a cup game. And you're shifting the 8 to move, and it's going to land where? Underneath the 4. So it's not 8 divided by 4, it's 4 divided by 8. Totally different answer. Now let me show you what I mean by simplify in one direction and solve in the other. Hey Lucas, will you take your AirPod out? So from here to here, that was bad. From here to here, we simplified. And then when we got here, we did what? We solved. So that's the difference between the two. First, you got to clean it up and get it to where, there's no like terms left. When you get to this point, now you need to start shifting things to the other side. Then you can solve it, okay? All right, so that's solving multi-step equations. You have 2 of those on your Chapter R exam review. The nice thing about solving an equation, how do you check it before you wreck it? Plug it back in. go to your calculator and you can type the left side in your calculator, and wherever there's an X, you would type 1/2, hit enter, leave it, then type the right side, hit enter, and they should match. That's how you know you got it right, okay? So this is one of those problems that you can check yourself. Next, solving quadratics. Let me show you how to organize this. This is the title. Here's our first question. This is where I'm reminding you of something, and then we have 2 more practice questions because we're doing one of each. I really want to get rid of that one. I'm going to change. I want to do a quadratic formula. So don't write that one. So write your 2 practice problems. And I'll come up with a quadratic one. Oh, I already have one. It's right there. My little post-it from last year. Including quadratic. Alright, so while you're writing that down, I'm going to talk to you about quadratics. Quadratics are polynomials of degree 2. Degree 2. There are 3 ways to write or to solve a quadratic. The first is factoring, and that only works if you will factor. The second is solving by square roots, and you can only do that if one specific detail is met, and I'll show you what it is. And then the third and final way, which works every time but it takes longer, is the quadratic formula. Hence the reason it's called the formula, because it works every time, but it takes longer. This is considered the standard form for a quadratic. Ax squared plus bx plus c, that's the standard form, which just means the term with the square needs to be in the front, the term with just x needs to be in the middle, and the constant needs to be at the end. I'm going to show you an example of all 3 types of scenarios. This should come back to you, I hope. We've already spent time on factoring. So solving by factoring, the good news is you already have refreshed on factoring. There's just one additional step after it to solve it. With factoring and the quadratic formula, you want everything to one side. With factoring and the quadratic formula, I don't know if you want to color coordinate this, but you want it in standard form. The only one that doesn't need to be in standard form is when you're solving by square roots, which does not happen a lot. So a good rule of thumb is get it in standard form, because then you can still recognize if you need to solve it by square roots, and then it's easy to change it. Okay, so number 1 is not in standard form because it is not equal to 0. That's how you know when it's in standard form, when it's equal to 0. Okay, that kind of looks like a little emoji, but it's supposed to just let you know that when it's equal to 0, it's in standard form. So I'm going to subtract the 4 to the left. Okay, and now I'm going to factor. Pay attention to what A is in case you ever overlook A by accident. Always train yourself to look at A. Since A is 1, when we come up with our numbers, we can go straight to parentheses, right? If A is not 1, then you're going to have to either do the grouping method or the fraction method. Which remind me to show you that because it really saves. How many of you have kind of adopted the fraction method and you appreciate the time it saves? Yeah. Let me show you the fraction method in Flex because it helps tremendously on time. All right, so A times C is -4. this little thing is just to help you organize your numbers. What multiplies to give me negative 4 and adds to give me negative 3? Negative 4 and positive 1. So because A is 1, I can't stress this enough because I saw one person taking this shortcut when you weren't supposed to last week, and I don't want it to confuse you. When A is 1 and you come up with your numbers, that is the only time you can go straight to parentheses. That is the only time you can do that. If A is not 1, then you have more work to do to factor it. Okay, this is what we are used to getting to. Remember from Algebra 2, this is the zero product property. You've got this crap times this crap equals what? 0. There's only one way that that can happen, and that's if one of those pieces of crap is the number 0. So you just pull both of them out, set them equal to 0, and solve, and that's your solutions. Now some of these, as you do this over and over, you can solve it in your head, but I'm just showing you the work that would be involved. So the solutions here are 4 and negative 1. Okay, that was an example of factoring. Here's an example of solving by square roots. Notice there is no bx term. Do you notice how there's no middle x term? There's no x to the first power. If you look at it, it says x squared minus 9. So the x squared is that leading term, minus 9 is the constant. What's missing? The 3. What? I think you're already solving it. What's missing? The x to the first power term is missing, right? When you recognize that there is just the single x squared term, you can solve by square roots. And I would advise it because it's a lot faster. So, how do you solve by square roots? You need to isolate the I'm going to put it's the x squared, or sometimes it might be parentheses squared. I'll show you an example of that. But you're going to isolate what's being squared. Get it by itself. So in this case, I need to add 9 to the right. Now what's being squared is by itself, which means you're ready to square root both sides. When you square root both sides, there is a default answer that comes next, and it's every single time. I put it in green because it gets overlooked, it gets left off, but it is if you square rooted, the next line better say plus or minus, positive, negative. So the answer here would be x is positive, negative 3. If you don't show positive, negative, that means you've left off negative 3, which means you've lost half the answer. Does that make sense? Now you might wonder, why is it positive, negative 3? Remember when you're square rooting, you're saying what number times itself will give me 9. Well, 3 times 3 is 9, right? But then also negative 3 times negative 3 is still 9. So there's 2 answers there. And no, that's not a minus 1 point. That's minus half, because that's half. And it, like, there's 2 answers. You only write positive 3. That's half credit. You know what I mean? You would only be indicating half of the answer choices. And there's actually 2 answers there. So just train yourself. When you square root, next line, bam, positive, negative. Okay? me show you, we're not solving them, but I want to show you, I'm going to put IE. If you had, say, 5x squared minus 125 equals 0, and then what if you had 4 parentheses x minus 2 squared equals 8? Okay, so look at those two examples. They're slightly different than the one we just did. Here's the difference. I'm going to highlight it. When you get what's squared here by itself, you would add the 125, and then I've seen people square root the next step. This is still in the way. There's a coefficient in front of what's being squared that you would have to divide by first, then square root. Does that make sense? Here, this entire set of parentheses is being squared, so that's got to go. And then you can square root. And let me show you, if you, this is going to be ugly, I probably should, oh well. Divide by 4. Told you it's going to be ugly. Divide by 4. And then now you would square root both sides. When you square root that binomial, it will drop the exponent and you're just left with what's in the parentheses. When you square root this, you would simply write that you've square rooted it. And then technically you would add 2 to the right, and those would not be combinable because one's a radical, one's not. So you just write x equals 2 plus minus square root 2. I actually like those because there's nothing to do. It is what it is, and it just shoves over to the right. But those are some more examples of what could happen. And this should be coming back to you from Algebra 2. Yes? Now let's practice the quadratic formula. Okay, that was example 2, so here's 3. Solve 2x squared plus 5x equals 3. Can I solve it by square roots? No, it's got all 3 terms, so that's how you know you can't go that route. If you cannot solve it by square roots, you need it all to one side. So I'm going to subtract 3 over. Now you might say that you can factor it, and you actually can, but I don't want to factor it. I want to pretend like we can't factor it. We're going to do quadratic formula, okay? The quadratic formula, as you recall, negative, so you're solving, my mind's racing faster than my mouth can talk. The quadratic formula's purpose is to be able to solve a quadratic equation without having to worry about, will it factor? Do I need to solve by square roots? What if it won't factor? What if I can't solve by square roots? Enter the quadratic formula. It works every time. It is time consuming. It is sometimes not conducive, like to the formatting of the way the answer you want, but it is something you can fall back on and solve. Like if I throw a factoring problem at you and you can't factor it, you could do the quadratic formula and then work backwards from the answers. Here's the formula. Negative b plus minus square root. B squared minus 4ac all over 2a. Because of this, right here, there are 2 numbers when you write the quadratic formula out. Because of the plus minus, there are actually 2 numbers there. No, I'm not expecting you to memorize the quadratic formula, although you probably do have it memorized. No. Yes. My teacher sang it in whatever grade. She sang it to the tune of Frere Jacques, which is Father John. I'm not going to do that. I know. Sorry. Just not feeling it this morning. Okay. How do you do the quadratic formula? Once you get everything to one side, you identify your A, your B, and your C, and then you plug it in. Now, I'm going to show you a technique. If you don't like it, then don't do it. You may like it. The quadratic formula has so much going on. When I taught this to sophomores in geometry, they did not do well at organizing it, especially around this part right here. So I came up with a method. It's pretty crappy. You'll see why. Do you remember the vocab word for this? No. Do you remember the vocab word for this? Notice I didn't highlight the square root. It's called the discriminant. Not discriminate, it's discriminant. And it dictates how many and what type of answers your equation has. And that's because what is the rule in math, y'all, with square roots? What can you not do with square roots? You can't take the square root of a negative, because then it pushes you into imaginary numbers, right? So because there's a square root here, there's a rule in math: no negatives allowed. Well, if that discriminant is negative, then this entire thing is imaginary. Does that make sense? If that discriminant is positive, then this entire thing is two real numbers. If that discriminant is the number 0, specifically, what's the square root of 0? 0. Which means when you add 0, won't that be the same thing as when you subtract 0? So if the discriminant is 0, then this entire thing has just one answer. Because there's no, add, subtract 0 does nothing to change it. So here's the method for solving by square roots that I taught my sophomores. That crap, that's what I made them call it, the discriminant, that crap, do it first. B squared minus 4AC by itself. Don't do it under the radical. Plug it in. So you got 5 squared minus 4AC. Then you go straight to your calculator and you type that in. And you will get a pretty number every time. And that's because we did not put the square root. We did that by design. We don't want the square root there because we want a pretty number here. So type that in. 25 minus 4 times 2 times negative 3. What'd you get? You get 49. See? Told you it's pretty. And then now, plug it in. Finish it. X equals negative B plus minus square root of that crap, which looks a lot better, over 2 times A. And now all you have to do is clean up that. You don't have to clean up all of this inside of this at the same time as you're cleaning up the entire fraction. So you're just separating. You're doing the crap first, and then you plug it in. What is the square root of 49? 7. Don't forget it is positive negative 7, right? And then this is over 4. And then now separate those and finish it. So there's 2 different expressions here. You've got the plus, and then you've got the minus. Plus 7 over 4, you've got minus 7 over 4. negative 12 over 4. Y'all with me? All right, one last thing to refresh you on. Solving literal equations. I was going to give you this, but I feel like it might be kind of overkill. Let's see how you do with just my notes, and then if I think you need that little extra piece, I'll give it to you to glue in your notes. Do you know what literary means? Or literacy? What is it referring to? Literary, literacy. What? Writing, right? Letters. Reading, writing, yes? Okay. Literal equations are equations with mostly letters. Might be a number here or there, but it's mostly just a ton of letters. Okay? Here is the literal equation that I want you to solve for L. Write it down. Then I'm going to give you some tips. You know it's a literal equation when it has more than one variable in it, okay? Because the only equations we've had so far were multi-step and quadratics, and those all involved x. Now we've got L, W, and P. By the way, do you recognize this formula? What? Perimeter. Who said that? Yes, it is the perimeter formula for a rectangle, because you have 2 lengths and 2 widths. Solving literal equations should be easy. Don't complicate it by trying to make it mathematical. It is not really mathematical. It is a cup game. It's a shuffling of cups. You got multiple cups up here, and you're going to shuffle them. The way you shuffle them is the opposite operation of whatever you see. Which one do I want by itself? I want that by itself. Okay? So think of the order of operations in reverse for solving. You can't simplify any of this crap because none of the variables match. You'll never be able to simplify it. It's just immediately shuffling, solving. So if I want that by itself, this entire cup has got to go, right? So shuffle it to the right using what method? Like, how do I undo this? Subtraction. Now, come over here. It helps to write it, but it will not have a like term. It's not going to have any like terms. So you write exactly what you see. I see P minus 2W. Now, the goal was L by itself. What's in the way? 2. How's it attached? Multiplication, so I'm going to move it by division. Normally, I don't suggest to come over here and draw one big fraction bar, but with solving literal equations, I do. Okay? Go over there, write your big fraction bar, and that's exactly what the answer is. equations are ugly, but you're not supposed to understand what it, like you're not trying to actually interpret it. You're just rearranging the pieces through the opposite mathematical operation until you get the one letter by itself. What if we came down to the end and it looked like this? What if we came down to the end and it looked like that? I would want you to be intuitive enough to recognize that the two you just divided, right, will actually go into each piece. Over here it would not because of this. You see it? Is that yours? Oh, okay. So you need to be intuitive enough, because remember, when you come in here, you level up. Don't leave me with that. You need to recognize, oh, hey, that actually will go in here, and it'll go in there. So the answer here would actually be 2p minus w. You need to be able to get there, okay? All right, so these are so simple. I feel like we should do maybe 2 more because it's just shuffling, but I want to make sure you're doing it right. So let's do another one. See, that was, I want you to solve for A. Okay, recognize what needs to be by itself. You cannot do anything to what's directly attached to it yet until it is just that term by itself on that one side of the equal sign. So first I need to shuffle by to the right by subtraction. Now that you're starting to understand it, you can visualize, okay, so that's going to move over here to the right. It's going to be subtracted. Right? And then now this needs to be by itself. Divide by x. So you are just writing what you say you need to do. Did you say this is your kind of math? I love literal.
Whatever we were doing before is not.
I love literal equations. Some people can't stand them, and I don't. It's like you're not looking at it right. It's just shuffling. I know, right? Now, if you stop here, don't write this on your paper because I'm about to erase it. But if you stop here, if you said, "Oh, that's my answer," you didn't get A by itself. So be careful. Make sure. If you need a highlighter during the test, I don't care. That's fine. Make sure whatever letter I say to get by itself is what's by itself, and before you say you're done. Okay. Let's do one more. Now here's where Adeline may throw a shoe at me. So sometimes you may have to get creative with it. You should see it, but so the goal is solve for B, and this is where having a highlighter during the test may help. So solve for B. Okay, well, I have a problem that I've not had yet. Then you can't add those together, right? What? you divide by CD here, you're creating an issue. You're overthinking it. What do they have in common? What do the terms have? Like, here's the terms, right? There's a term and a term. What do they have in common? B. Pull it out by factoring to the front. So I would be left with 1 plus CD. Bring this down. There's my GCF. This was an example of when there's a GCF. So I don't know if you want to make a note. But there was a GCF of what you needed by itself. So if we pull the GCF out, you're just dividing, right? You said that they have, imagine if it were a 4. 4 plus 4CD. You could factor a 4 to the front and you'd be left with 1 plus CD. Don't let the letter throw you off. Pretend it's a number if you need to see that you can do that. You can manipulate and factor that to the front. Now I have this crap here is in the way of B being by itself. How's it attached? Multiplication. So just shuffle that crap right over here underneath the A, and you're done. Where'd I lose you? Look at that. Right? Hit X by itself. What do they have in common? You factored. You factored. You factored GCF.
Oh, yeah.
Look, it's the same thing as like this. Say this was x squared plus x. Right? What do they have in common? They have an x. You can factor an x out. Of course, there would still be one, but you're just factoring a GCF. What if it was look at that. Factor 4 to the front, I'm left with x plus 1. Same exact concept, it's B. You can't add these together because of the CD. They're not like terms. And you don't want to add them together. You don't want to add them together either, because it would be really ugly. Okay, I figured I was going to collect it just in case. Yes.